Okay, in this video, we are going to talk about eigenfunctions and eigenvalues. So I will take an example, right? Let's take a function of x, right, as sine 2x. This is our function, right? And let's take an operator, this one. This is an operator. So I will use this function with this operator, right? D squared over dx squared sine 2x. Okay, so this is a simple derivation. I hope you remember how to derivate something, derivate this kind of function, right? We first derivate this whole one, so this is sine. Okay, this is sine, so I will take 1 d over dx, this sine 2x derivated by x, so we have cos 2x, and then we are moving to inside, right? Then we are moving to inside, so inside we have 2x, then we have to derivate the 2x, so it will take us to 2. Now we have to derivate this whole thing again, so this number 2 here, this number 2 is a constant, so we can take him way over, so I will take 2. Now we have to derivate this cos 2x, like I told here. First we have to derivate this whole thing, so derivation of cos is minus sine, right? Minus sine 2x. Now we have to move inside, right? Now we have to move inside again because we are doing a derivation, so we have to move in again. So derivation of 2x is again 2. Here we have 2 here also, so we have the answer 2 by 2 minus 4 sine 2x. Now here look at this, guys. So here we have sine 2x, which is our function, right? Our function here. We got our function here and we got a constant. So here we got our same function, right? We got our same function and a constant. So we say this fx is an eigenfunction of the operator here, right? We are talking about eigenfunctions with the operators, right? This our function is an eigenfunction of operator here. Why? Because when we are doing this operation, right? When we are doing this operation, we got the same function again. We got the same function again with a constant. That's the definition of an eigenfunction, right? So we say this our function over here is an eigenfunction of this operator. Why? Because we got the same function over here with a constant. This doesn't work if we got an answer like this, minus 4x sine 2x, right? Here we got I'm just taking another occasion, right? This is not this example, so this is the same function fx, but here we didn't get a constant. This is not a constant, right? If our answer if the answer we got is like this, right? If the answer is like this, then this function is not a eigenfunction. So in order to become an eigenfunction, okay, in order to become an eigenfunction, it must be look like this: same function, and a constant. And what is eigenvalues? We already taken them. What is eigenvalues? This one here. We are obtaining a constant value along with our function. This constant value is called eigenvalue, right? So this k is the eigenvalue. So in this example, right, eigenvalue is equal to minus 4. This is the eigenvalue, and this function is an eigenfunction of this operator, right? Of this operator. Okay, I will take another example here. let's look at this. Give me a second to clean this up. I will take another this here. Okay, I will take an example like this. Okay, I'm taking the same function, okay, sine 2x, but now I'm taking the operator d over dx. So let's see what is the eigenfunction, or is there any eigenfunction or eigenvalues, right? So I'm doing the operation d over dx with sine 2x. The first we have to take the whole one. Sine 2x is, we have sine 2x, so by derivation we have cos 2x. Then we move into inside, over 2. So we got an answer 2 over cos 2x. So as you can see guys, here we didn't obtain the same function here, right? Yes, we got a constant, but we didn't get the same function like here. So we call this fx is not an eigenfunction of this operator, right? This function is not an eigenfunction of this operator. So as you can see, this eigenfunction and the operator, they are working together, right? If we can obtain an eigenfunction, right? If our function is an eigenfunction, then surely it has an eigenvalue. Here we didn't get an eigenfunction, which means there are no eigenvalues. So I hope you got it.